In this video, we're going to take a look at the time value of money concepts, the APR, which is an annual percentage rate, and an effective annual rate, or an EAR. Let's start with an example. The other day I saw a credit card advertisement with an interest rate of 18.25%, and next to that in parentheses it said a 0.05% periodic daily rate. The first thing this tells me is that interest on this credit card will compound on a daily basis. Our daily rate times 365 gives us the APR, which is the advertised 18.25%. But we'll find this is less than the effective rate we pay if we actually borrow money using this credit card. What if we were to borrow $100 and not make any payments for a year? How much would we owe at the end of the year? Well, the future value we call is our present value times 1 plus r to the n, where in this case our r is our 0.05% daily rate. So 1 plus 0.0005 to the 365th power gives us a future value of $120.02. And the first thing we can observe is that this is more than the $118.25 that we might expect to owe at an 18.25% APR, because with simple interest, that's how much we would owe. Recall, for simple interest, we simply take our initial balance and add to that the balance times the 18.25% interest rate. But in this case, we have compounding. Remember compounding? When we earn or pay interest on interest? This brings us to our effective annual rent, or EAR. The EAR is the amount of interest we actually will pay if we borrow money using this credit card that has daily compounding. In this case, the EAR is 20.02%, and we can find this by taking the amount of interest we paid in the first year and dividing it by the $100 that we borrowed. Alternatively, we can use a formula that relates the EAR, or effective annual rate, with the APR. Our EAR will equal 1 plus the 0.1825 or 18.25% interest rate divided by 365 days, because we had daily compounding, to the 365th power. We then subtract 1 and we find our EAR is 20.02%. We can solve the same thing using our financial calculator. With your financial calculator, we would enter 365 number of periods. For our interest rate, enter in 18.25 and then divide that by 365. Enter -1 for our present value, 0 for the payment, and then when we solve for the future value, we'll get 1.2002. We subtract 1 to get the EAR of 0.2002 or 20.02%. The EAR is the actual rate paid or received after accounting for compounding that occurs during the year or period of time. If we want to compare two alternative investments with different compounding, we're going to need to compute the EAR for those and then use that rate for comparison. Let's compare the difference in future values over a period of time of a $1,000 investment at a 10% annual interest rate with annual compounding, quarterly compounding, and daily compounding. We can watch the graph down below. Early on, there's not a lot of difference in the future value of these investments. They grow at roughly the same rate. But over time, we start seeing a significant difference in the amount of our future value of our investment. In fact, over a 40-year period with annual compounding, that initial investment of $1,000 would grow to $45,000. With quarterly compounding, it would grow to $51,000. And with daily compounding, it would grow to $54,568. So it is important to notice whether or not we have daily, quarterly, annual, or monthly compounding. So again, if we want to compare alternative investments with different compounding periods, we're going to need to compute the EAR and use that for comparison. And we can use our mathematical formula calculator to convert an APR to an EAR. Or we can use our financial calculator. Let's go ahead and look and see how we would do it with our financial calculator and make some comparisons. If we have a 12% annual percentage rate and annual compounding, at the end of the year, we will have earned an effective interest rate of 12%. However, if we have quarterly compounding, we'll put 4 for the number of periods. Our interest rate now will be 12 divided by 4. Again, the same present value. 0 for the payment. We would compute the future value and get 1.1255, which tells us our EAR with quarterly compounding is 12.55%. With monthly compounding, we would have 12 for the number of periods. We would have 12 divided by 12 for the interest rate. We would solve for the future value and get 1.1268, or 12.68% effective annual rate. With weekly compounding, we have 52 for our number of periods, 12 divided by 52 for our interest rate, and we have an EAR of 12.73%. With daily compounding, we use 365 for our number of periods, 12 divided by 365 for our interest rate. We solve for the future value, and we find we have an EAR of 12.75%. Now, if we have infinite compounding, we can use logarithms and solve our equation mathematically, but it's just as easy to use your financial calculator. Pick a big number for n, say 10,000. Then for our interest rate, we'll have 12 divided by 10,000, 1 for the present value, and again we solve for the future value, and we get the same 1.1275, which again, our EAR is 12.75%. So quickly we can see, in investing our money, we would prefer a frequent level of compounding, weekly, daily, or even better yet, infinite compounding. But if we are borrowing money, we would prefer just to borrow money with a loan with annual compounding. While calculating our EAR is important for comparing investment alternatives, the APR, or annual percentage rate, is the rate that's quoted by law. By definition, the APR equals our periodic interest rate times the number of periods per year. To convert an EAR to an APR, we can use the following formula, or we can use our financial calculators. To use the formula, we'll go ahead and substitute in for our M will be our compounding frequency, which in our case was 365 days. Our EAR for our credit card offer was, recall, 0.2002 or 20.02%. We'll take that to the 1 over 365 power. We'll subtract 1, and in doing so we would get 0.1825, or an APR of 18.25%. Let's assume we have an investment that promises a 6% EAR, annual effective rate. And if we have annual compounding, then not surprising, our APR and our EAR would be the same since we compound only once per year. But what if instead we had quarterly compounding? With quarterly compounding, we're going to want to set 4 for the number of periods. Again, our present value will be 1, or negative 1 on your financial calculator, 0 for the payment, and we're going to want to enter in 1.06, which is 1 plus the EAR for the future value. Again, the idea being if we put in $1 today as a present value, we would have a future value of $1.06 if we could earn a 6% EAR. Now we need to solve for the quarterly interest rate, and we get a quarterly interest rate of 1.467%. We multiply that by 4 to get an APR of 5.87%. What this effectively is telling us is we would be just as happy with an investment that had a 5.7% APR with quarterly compounding as we would with an investment with a 6% APR with annual compounding. What if instead we had monthly compounding? Well, now in your financial calculator, set n to 12. Again, our present value will be $1. The payment will be 0, And a 6% EAR means our $1 investment will grow to $1.06 at the end of the year. So we'll set that as our future value. And finally, we will solve for our interest rate. Since we have a monthly time period, that is n equals 12, the interest rate we solve for will be a monthly interest rate. And we take that monthly interest rate of 0.487% and multiply it by 12 to get our APR of 5.84%. So a 5.84% APR with monthly compounding gives us the same return as a 5.87% APR with quarterly compounding, or a 6% stated APR with annual compounding. Now, what if we had weekly compounding? In this case, n will be 52. Our future value again will be the 1.06. And we will once again solve for our, in this case, weekly interest rate, which is 0.112%. To get the APR, we take that weekly interest rate and multiply it by 52, and we get an APR of 5.83%. With daily compounding, again, our goal is to have a 6% EAR, so we'll enter that as our future value, the 1.06. We have 0 for our payment. Our initial investment would have been $1, and again, our $1 growing to $1.06. That is what we mean by an effective interest rate of 6%. We'll put 365 in for the number of periods, and when we solve then for an interest rate, since we have 365 days, we get a daily interest rate of 0.016, and multiplying that by 365 gives us again our APR of 5.83%. Let's work through a problem. How much will we have in 15 years if we invest $10,000 today at a 9% annual interest rate with weekly compounding? Our initial investment today is our $10,000. We have weekly compounding for 15 years, so we're going to take 15 and multiply it by 52 for the number of periods. Our interest rate was 9%, but again, since we have weekly compounding, we want to take 9 divided by 52 for our interest rate. We have 0 for our payment since we don't involve an annuity here, and we solve for the future value. And that $10,000 investment would grow to $38,529. Let's consider another problem. How many years will it take for a $1,000 monthly investment to double, or a $1,000 investment to double, if we can earn a 12% annual APR with monthly compounding? So we've got a $1,000 initial investment. Let's enter that with a negative sign since money we're putting in. And we want our money to double, so it should grow to $2,000. We're not talking about annuities, we're talking about a lump sum, so we'll put 0 for our payment. For our interest rate, we're going to enter 1, which is our 12% annual interest rate divided by 12 since we have monthly compounding. And finally, we'll solve for the number of months, and we get 69.66 months. And if we divide that by 12, we would find we have 5.8 years is the length of time we take for our investment to double. Let's consider another problem. How many years will it take for a $1,000 investment to double if we can earn an 8% annual interest rate, EAR, with quarterly compounding? Since we already have an effective annual rate, we don't need to worry about the compounding frequency. It's already been taken into account. So we'll begin with our $1,000 initial investment. For our money to double, it will grow to $2,000. We're not talking about an annuity, so we'll put 0 for payments. And again, our 8% is an EAR rather than an APR, so we don't need to worry about compounding frequency. We'll put 8% for our interest rate and solve for the number of periods. Since we have an annual interest rate, we have an annual number of periods, and it will take 9.01 years for our money to double. A couple things to remember. We always need to make sure that the interest rate and the time period match. So if we're looking at annual periods, we need to use annual interest rates. And if we're looking at monthly periods, we would need to use monthly rates, and so on.